video, we're going to talk about diluting concentrated solutions. And this is another really common sort of calculation you would do if you're working in a lab. Sometimes when you order a stock chemical, it actually comes as a solution already. For example, hydrochloric acid typically comes in 12 molar concentrated solutions. And if you wanted a 0.75 molar solution for a particular experiment, you would need to dilute that 12 molar solution down to the 0.175 molar solution. So diluting concentrated solutions. So diluting concentrated solutions. Be really careful. In our next video, we're actually going to do stoichiometry. Do not use this, you're going to end up with a formula. Do not use this formula for stoichiometry problems. All we're doing here is we're taking one type of solution, hydrochloric acid in the example I just gave you, and we're diluting it to a less concentrated solution of the same thing. So we're going from hydrochloric acid to hydrochloric acid. If you had to go from hydrochloric acid to, let's say, sodium chloride, this doesn't work. You actually have to use your balanced equation, right? Remember, anytime you go from one substance to a different substance, you need the coefficients in our balanced equation. Here, it's the same sort of compound. So whatever compound you're starting out with, it's the same compound you're ending up with. So again, do not use this for stoichiometry. That's a really, really common thing that students do. It's the wrong application for this. Sometimes you get lucky and you get the right answer, but I will mark it wrong because you did the problem incorrectly. So just be really careful. This is only for going between different concentrations or volumes of the same substance. Same only. Right, for example, if I'm going from a 12 molar hydrochloric acid solution, and let's say we need a 3 molar, and this isn't a reaction arrow, it's just a going to arrow, 3 molar hydrochloric acid solution, right? We're going from HCl to HCl, so same substance. If you're doing a problem where you have to go from HCl to something that's not HCl, then this is not how we want to do it. So again, diluting concentrated solutions is literally just for doing that. So part that we want to remember is when we are diluting our solution, what we're doing is we're adding solvent, and then that's making my concentration less. What we're not doing is removing solute, right? When I go from that 12 molar solution, right, 12 moles per liter, to the 3 molar solution, 3 moles per liter, I'm not taking some sort of little microscopic tweezers and pulling out moles of hydrochloric acid. We can't do that. The only thing I can do is increase the volume, which then makes my concentration, right, that ratio smaller. So when diluting concentrated solutions, remember the number of moles of solute remains the same. Right? If we were to add more moles, it actually becomes more concentrated, and we can't remove moles. Once they're dissolved in solution, I can't pull them out. So when we're diluting our solution, the number of moles of solute remains the same. It's the volume that changes. Right? So, and this is important. This is a really common question I ask. So the number of moles remains the same when we're diluting it. So be careful for that. It's going to be our volume that changes. So if we remember molarity, capital M, right, that was equal to moles of solute And then it was per liter of solvent, or sorry, liter of solution, important, it's solution on the bottom of the total. Liter is a unit for volume, so I'm actually going to put a V on the bottom for my volume. So moles of solute per volume, particularly liters, but again, volume of solution on the bottom. I'm going to rearrange this to solve for moles. So when I do that, moles of my solute equals my molarity, so capital M, times V for my volume. So if I have my original solution, right, my original concentration, so I'm going to put a 1 there, and then my original volume, right, and then I'm going to dilute it. So I'm going to have a new concentration, right, it's going to be less. I'm going to have a new volume, it's going to be bigger, right, we're adding solvent to it, which is making my concentration smaller. I'm going to put some 2's here because it's my new volume, which is bigger, right? My new concentration, which is smaller, but we didn't mess with the number of moles, right? The number of moles did not change, right? Back up to this sentence. When diluting solutions, the number of moles of the solute remains the same. So these two numbers are equal, right? They didn't change. So if moles is equal to M1 times V1, and then moles is also equal to M2 times V2, then using whatever that mathematical property is, I don't remember the name, but if something's equal to a number and something else is equal to the same number, then those two somethings, right, are equal to each other. So M1, my original concentration, times V1, my original volume, is equal to M2, my new concentration, times V2, my new volume. And then this is the formula we're going to use for diluting solutions. Again, only for diluting solutions. N-O-T, capital, couple underlines, not for stoichiometry. We'll do stoichiometry in the next video. Right? We're going from one substance here to the same exact substance. One substance to a different substance, you need to use your balanced chemical equation. So an example for us. How many milliliters of a 12.0 molar hydrochloric acid solution do we need to add to produce, forgot my C, let's do 250.00 milliliters of a 5.25 molar solution. So this is a diluting, right? We can use our M1V1 equals M2V2 equation because I'm going from HCl to HCl. I guess I didn't write that, but because I didn't write another one, we'll stick it in there. It's HCl to HCl. So I can just use that equation. What I like to do, anytime I have an equation like that, I like to kind of make a list of what's equal to what before I plug them in. If you were given one volume, let's say you have, well, we can do another example like that, but let's say you were given both volumes and you were solving for a concentration, the volumes would have to have the same unit. So if one was in liters and the other one's in milliliters, I would have to convert them both to the same. It wouldn't matter which one it was as long as they were the same. So M2V2, sorry. Having a hard time talking and writing at the same time. So I'm going to make a list. So honestly, it doesn't matter which ones are the ones or the twos. If you want to make the ones the higher concentration and the twos the lower concentration, it doesn't matter. What matters is that you keep the right volume with the right concentration. So if I go and look at this, right, it's 250 milliliters of a 5.25 molar solution. So long as I keep those together, it doesn't matter if I make them the ones or if I make them the twos. it only matters that I keep them together. If I make the 250 milliliters volume 1 and then the 5.25 molar solution molarity 2, then I'm gonna get it wrong. So just make sure you keep the volume and the concentrations that go together. So I'm gonna do the 12 molar for the original, and then this is going to be my unknown, right? That's what we're solving for. How many milliliters of that solution? So that's the pair that goes together. And then my new concentration, 5.25 molar. And then my new volume, 250.00 milliliters. And then it's just a matter of plugging them into the formula and solving for my unknown. So 12.0 molar times, because I don't need those parentheses, times V1. They didn't hurt anything, but then 5.25 molar multiplied by 250.00 milliliters. So solving for V1. And I got, so I only want 3 significant digits, so I guess 109 milliliters. So what this is telling me, if I was to take 109 milliliters of my 12 molar solution, bring the total volume up to 250 milliliters, then my new concentration would be 5.25 molar. Let's do one more. I said I would, where I actually give you the 2 volumes. So let's do if we add 250.00 milliliters of a, let's do a 3.84, I'm just making stuff up, molar sodium hydroxide solution to water. These are aqueous solutions, and dilute to a final volume of 1.50 liters. What is the concentration of this solution? So again, I like to make a list. You don't have to, you can go right to the formula. I just find that sometimes I'll plug the wrong numbers in the wrong spot. Like I won't keep the right volume and the right concentration together. But if I make a list of them and then plug them in, I tend not to goof those up. So again, you need to just make sure that the pairs go together. So I have 250 milliliters of a 3.84 solution. So those go together. Doesn't matter if you make them of the 1s or the 2s, they just have to go together. So 3.84 molar, 250.00 milliliters. My new concentration, right, what is the concentration of the solution? That's my unknown. And then my final volume, 1.50 liters. So from a unit standpoint, those volumes need to cancel, right? If I go back up to this one, I didn't really talk about units much, right? But what I did is I took the molarity, multiplied it by milliliters, and then I divided it by molarity, right? If I was to rewrite it, 5.25 molar, 250.00 milliliters, and then 12.0 molar, right? Mathematically, that's what we did to solve. Oop, V1. Sorry guys, I didn't realize I goofed that up before. Glad I went back. V1. That's what we're solving for. These cancel, right? It's the same number on top as it is on the bottom, and then my units came out in milliliters. So here, when I plug it in, those units have to be the same, otherwise they're not going to cancel. It doesn't matter what they are, it only matters that they're the same. So if I want to convert 250 milliliters to liters, that's fine. If I want to convert 1.50 liters to milliliters, that's also fine. It doesn't matter. They just have to be the same units. I'm going to convert my milliliters to liters, but again, if you want to do it the other way and then compare your answer to my answer, that would be cool. We should get the same thing. So I'm going to move this over 3 places, right? There's 10 to the third milliliters in a liter. So divide by 10 to the third. And I get 0.25000, don't drop any digits, liters. So now my units will work out when we do it. So 3.84 molar M1 times V1, 0.25000 liters, is equal to M2, my unknown, multiplied by 1.50 liters. So solving for M2, those liters are going to cancel, and we'll have molarity as my units. And I get 0.640 molar. Right, my calculator is just telling me 0.64, but remember our calculators don't know significant digits, so you do need to add that 0 for it to be correct. So if I was to take 0.25 liters of a 3.84 molar solution, dilute the volume to 1.5 liters, the new concentration is 0.64 molar, 0.640 with sig figs.